Hello everybody, Mikael here, and today the topic is, well, programming in C, and we have come to the topic of file input output. So let's talk a bit about that. I have an agenda here. This is all about the chapter 7 in the book, in the input and output chapter in our programming in C language book. And the basic agenda is we're gonna talk about standard input and output, the three streams there: standard in, standard out, standard error. We're gonna see how we can open, close, create, read and write to a file, and we're gonna do it character by character, string by string. We're gonna do it with a struct or with a data structure. Just a blob of data, write and read to file. We're going to see what end of file is, EOF, well, end of file, that's it is. And we're going to talk a bit about error handling. How can we deal with error handling when we're working with the files? Because that could be an important thing to make our sort of programs more resilient to error conditions. So, let's start with the standard input and output. So we have three default streams. Standard in as the standard input. Here we use for scanf, or we sort of read input from the terminal from the user. Then we have the standard out, where we print stuff like printf. You have probably done that before. That is actually a printing to the standard out, and we show it in the terminal for that sake. Standard error perhaps you haven't used before, but that is the standard error output. So we are separating the standard output from the standard error output, and that is good for the user, because the user of our program can then filter what the program says as standard output, and when it comes an error message, because the error message are written to the standard error output. So that is a good thing. These default streams are set up by the operating system, so they exist when we sort of, well, start our program. Some more basic stuff. A stream consists of lines, okay, line, and each line ends with a new line character. This might then be true mainly when we talk about text file. Let's see how the file looks like when we come up to the later chapter here, where we talk about how can we save a struct to a file. But for now, text file, each line ends with a new line character, and the end of file constant means that the stream is empty. There is no more to read from that stream for now. So this is just an example to get going how we can work with streams. And we have the get char and the put char functions, and they are writing to streams. We don't see it actually, but they are writing to standard input, writing to standard output, and they're reading from standard input. So I've created a small program just to show it off how it works here. So I'm doing a while loop. I'm reading from using get char from the standard input. I'm placing the char by char in the ch variable there, and I'm continuing to do that until I get an end of file character, end of file value. And then I just put char. I put the character, I change it to lowercase just to make a change to it, and write it out to standard output, that is. So this is an eternal loop until I create an end of file status, and I can do that pressing Ctrl D on Linux terminal. I actually think that is the same on Windows terminal. So Ctrl D would sort of end this loop. Okay, so that is how get char and put char is working on standard in and standard out, and we're going to see the same sort of functions when we look at how we can do this with, in general, any type of file, any type of stream. But first we need to create the file pointer. We need to open a file. So we do this, we open the file, so we say what file name it has, or will have if we create it, and then we tell we're going to use this file for reading or writing or both. So when we open a file, we're going to get a file pointer back. And this file pointer doesn't in general point directly to the file, because it points to a structure of data containing information about the file. So it basically contains the location of the file buffer, where it is in the file system, current position in the buffer, so where are the file pointer now in the stream that we are working, or in the buffer. What mode the file have, is it read, is it write, or both? Have any errors occurred? So this is stored in this file pointer struct. It's also stored if we have encountered end of file here. So let's see how we can do this. We need a function or two to help us open the file here. So first I'm just creating the file pointer, and you see capital file FP there will be the pointer that is pointing to the struct of the file, and that is returned from fopen. So, and into the fopen I send the file name to open, and I send the mode. And when I'm happy with everything, I can just close the file pointer with fclose. The argument there, so file name is not much to say about, but the mode, the access mode. So the access mode could be R, W, or an A. So that is for read, write, or append. And we can also have them both. So R plus and W plus will be both read and write. A plus will be both read and append. And we can look a bit more into this file mode details actually. So the read, that opens a file for reading. The file must exist, otherwise it will be an error. Write, that creates and empties the file. So even if the file has content, that content is removed when we use this W. A appends to the file, so appends to the end of the file, and the file is created if it does not exist. Then we have R plus, that is open the file for both reading and writing, but the file must exist. And in differ than in V plus here, that creates an empty file for both reading and writing, empty file. So then the append plus opens a file for both reading and appending. So here is the example of how I open and close the file. So I'm creating the file pointer up there, so I have it. I'm creating a variable for holder of the file name, and then I just create and sort of making the file empty. I just creating it with fopen, V there, and then I'm going to close the file pointer. And then I'm going to open and close it again, but this time I open it as a read file, or read plus in this case, because I'm going to write to the file also. So I'm going to use a function here, if fpaths, to put a string to the file pointed to by the fp here, and then I'm just going to close it. So that is how we open and close the files, and actually also how we can write a string to the file. When we're working with files, it's really good to see what they actually are containing without the need of using the actual C program to check it out. So of course we can use the operating system, the terminal, to see how the file looks like. Here I'm doing it on a Linux terminal with ls-l file showing me the file and size of it. And if you're on the Windows, you should do dir instead. Then we can look at the content of the file, and we can do this with more file.txt, and we see that the file contains the string. We don't see the actual \n, the end of a line, new line character there, because it's just printed out. So we know it's actually there, but we don't really sort of see it. It's not a printable character, it's just a new line. So a bit about dealing with errors. When we open up a file, we should actually check if the error was sort of if there was an error or if the file pointer that we received is a valid struct. So when we get some problem with fopen, the file pointer back would contain the null value. So it's good to check it out with an if statement, check if the file pointer is null, and if it is, just create a error. And here I'm going to use the p-error function, and I'm going to write out the message, and p-error will add on to here the sort of more specific details, no such file or directory. And you see down here that p-error is actually a sort of it's a generic error message printer, and it prints the current value based on the external variable that is called as arno. So the value of arno is set by any C library functions when some error conditions are encountered. So this is good to use for any type of errors we could encounter in our C programs then. So let's see how we can write and read from and to the file, and let's start with character by character. And we have basically two functions to do this. Well, we have one for putting the character into the stream and one reading the character from the stream or file if you wish them. I have listed here put C and fput C, and I have also listed get C and fget C. So these are in general the same. There is a small implementation difference between them, that getC can be implemented as a macro, whereas fgetC is not implemented as a macro, but is then always known to be a function. So there are small parts that might be important difference among them, but if this is not an issue, you can use any of them. So let's see. Character is the character to be written and is passed as is int promotion. Okay, and then we have the pointer to the file object. Just a quick note on this integer promotion. This is some kind of sort of built into the C language. Like some data types that are sort of shorter than an int, they take up less space than an int. They are in general promoted up to have the size of an int or an unsigned int when an operation is performed of them. So basically all operations then when this integer promotion happens is that all operations are done on integers, even if we were using character or short int. So this is called integer promotion. So that's just a quick note on that. So here we get our small program reading a file char by char, and this is basically the same example structure where we have an eternal loop until we read fgetC, we read a character by character until we have reached the end of file, and for each time we do that, we do a fputC and we put it out to the standard output. So here standard output is a specific sort of file pointer that already exists and is open. Then we can just close it. Okay, so that is how to work file by read a file character by character, and we can also write character by character. If this character by character is not enough, then we can go with the string way. So we have a function called fputs, put S instead of C, where we can send in a whole string, so a null terminated sequence of character that are all written to the character. All the characters in the string are written, but the null character, the ending null terminating character, is not included when written to files. So that is good to know. So fputs, just write it all into the file. So here's an example of it. Open the file for writing, and I'm writing the fputs This is C programming with files \n, writing it to a file, and then I'm using hexdump. So hexdump is a good utility when we work with files, because I can see each position in the file, what it contains. Even if it's not a printable character, I can see that it is sort of not printed here. But for now, I'm just gonna do hexdump -c, and that is going to show me what the content is, and I see all the chars in this in the file, and including the \n character there. So that was fputs, putting a string, and then of course we have fgets, so we can get a string, read a string from file. So here we have a char string, and this char string here that needs to be an array where the string is to be stored. So we need to allocate memory for that part. And then we say maximum number of characters to read, and that should then correspond to how long is my array, how much memory have I allocated in my string here. So that says read at most n bytes, or it's actually n-1 bytes that we're going to read here, because the string there needs to have its final null terminating string character, and so that's why we only read n-1 bytes. Or it will stop reading when end of file is encountered or the new line character is encountered. So fgetString will get one line from the file. One could say so. Read one line basically up to end of line character, or at least or at most n-1 bytes of characters. Formatted input and output. We all knows about printf and scanf. I guess those are the two of the functions that you are using when you sort of first becoming a C programmer. And then we have the fprintf and fscanf version of them, where we can sort of pinpoint what stream we want to write to. So here we can make formatted output to the file, and we can also read each, well, from the file in a formatted way. So we're reading parts of the file and putting them into variables, for example, using fscanf. So formatted input and output, good to know. A bit more about error handling then. We have talked about the standard error stream, where we should put out error messages, and this is the same example that we had more or less before, that I printed the error using p-error. So here I'm doing it a bit different. I'm opening a file that does not exist, so my file pointer will be null. And then I'm going to use fprintf, so formatted printf, to the file, to the standard error file, you see that. And then I can sort of print an error message, and like adding exactly the file I was trying to open. So give the user a very verbose error message to sort of let him know, well, this happened. It's good to give some details also. Then we're going to do an exit here also. So exit is to exit from the program, and I'm going to do an exit with a failure status here. When we run a program here, the exit success constant that we usually do, that is a constant that has the value of 0. And when a program executes and executes with exit status 0, that is good, because that says good execution. Nothing happened. I'm happy. But when we sort of have an error in the program, we usually exit with a exit status of 1 or 2 perhaps. An exit failure here is a constant or define to the value of 1. So here down here, when I'm on my Linux machine and echo $? To get the latest exit status of the last command executed, I will get an 1 there saying that, well, something happening, so it wasn't good. And we can also see that the error message is printed there. Okay, good. Here are a few more functions that could be useful when we work with the error handling, when we sort of using the files. So we should sort of in general check that if an error occurs when we accessing, reading or writing to the file. An F error is one of those functions we can use here. So here I'm reading a character from the file, and I'm checking if if there is an error on this file pointer currently. I do that with F error. You remember perhaps I said that the structure for the file pointer contains the information if there has happened some type of error with it. And F error just checks the struct did any error happen, and if in that case, well, deal with it. In this case, I'm just gonna printf to the standard error that this type of error occurred. I failed to read it, and then I can actually sort of continue, so I don't need to exit. I could decide that this is a manageable error I have here, so I can just clear it. So this is clearing the error from the file pointer structures. So then I can basically move on in my program and do stuff, close the file or create it or whatever I want to do with it. I just say that this was a manageable error. So F error, clear error, and F end of file is also sort of acquainted to this. This could check if we have end of file for this sort of particular file pointer structures. So don't forget to sort of check and eventually clear the errors when you're working with the file. Good. Let's see how we can write a more complex data structure to a file. And I'm going to do an example here where I'm writing a struct to a file. And to do that, I'm going to use the function called fwrite. And fwrite writes a block of data to a file. And it basically is set up like this. First we have a pointer, and this pointer points to an array of elements. Okay, an array of elements. Good. Size, saying how large is each element in bytes. Okay, I can do that with the size of operator. And then I need to say, okay, how many elements are you going to write here? So let's think that this is an array of elements. How many elements do I have in this array? I need to tell that to fwrite, so they need how many elements they should write. And then we have the file pointer there. So I'm going to do an example using fwrite here. So I'm going to create a struct person here. I'm going to type def it to person. I'm going to have a surname, last name, and an age. And I'm going to create these as character arrays here. And then I'm going to sort of create the file pointer, the file name. I'm going to create two persons here. Moose, I'm going to initiate him, and I'm going to create person do and initiate him with the values into the struct there. And then I can do my work with fwrite. So I'm going to open the file for writing, and then I'm going to write them. I'm going to write them one by one here. So I actually don't have an array, but I'm going to send in the address to the struct here. So address to Moose and address to do. And I'm going to write the element here are size of person. Okay, and I'm only going to write one element here. So if let's say that I grab these two persons together in an array, so I had two elements, then I could do it with one fwrite, just adding the one there to two elements instead. But here I do it for in sort of two functions call after each other. Here I'm going to use hexdump to view the content of the file, so I can see what's in the file. -c will show both the hexadecimal value for each and every position in the file, so each byte written. And at this part I also see a printable version of the file. So any character that has a printable representation will show up here. So this is a really good tool to use when you are sort of inspecting files and working what are they containing. Really good to have this. Sometimes it's really hard to sort of work with files when you don't have access to this type of sort of tool then. You can also see here that if you go back there on the hexdump there, we can see that, okay, it contains Mikael, and then it's a ... And we see that these dots are represented by 0, 0, 0, 0. And this is basically the array. I allocated an array of 20 characters to contain the surname and the last name. So these zeros will then also be part of this struct when it's written to file here. So that's why we have a bunch of zeros. Okay, good. That was F right. If we for some reason want to read back the structure from the file, we can do that with fread. That works in the opposite way. So here we have the pointer, and a bit like the fputs and fgets with strings, we also need to take care of allocating a block of memory here with the minimum size of the amount of data that I'm going to read here. So the size is then set up of the size of each element's size, so the bytes of each element, and the number of elements that we sort of want to read. So here I could basically, if I'm going to read back the file I just created, I could do it with one call to fread. I just need to allocate enough memory to hold 2 persons in an array, and then I send the pointer to that array. Then I say, okay, it's a size of pointer and I have 2 elements, and just fread it into a structure. And then I can go again. So this is a nice way of working with sort of data and saving rather complex data structures to file. When we are working with this more complex data structure, perhaps we also want to move around in the file. Perhaps it's a really large file of this sort of records or structs, and I want to search it and find a particular sort of record or struct. So I'm moving around and I'm reading up one record at a time, and then I need sort of a function that can help me move around, and fseek does that for me. So fseek has a file pointer, and then it has an offset. How many steps should I move around in the file? And this offset is then added to a constant. And the constant is, should I start counting from the beginning of the file at the current position we are now, or from the end of the file? And combining these with the offsets, I could basically just move around at any position in the file. So I think we are closing in now. We are wrapping this up, and I'm just going to send a few useful file functions with you to go. We have ftell that will return the current position in the file. So that could be good when we're jumping around the file with fseek, and then, okay, I need to know where I am now, so give me the current position. Perhaps I want to do some calculation with it. So ftell will do that for me. Rewind file pointer is basically go back to the beginning of the file, and this could be a shortcut to do the same thing with fseek. UngetC is a function that could push back a character to the file. So that could be useful when you're sort of reading a character from the file, and then you're encountering a character that you don't want to read, so you want to put it back to the file. So then you can do that with one character, not more character. Only one character is guaranteed to be put back, and then you do that with ungetC. So well, that's that. And let's see what we have to summarize here. We did a lot of file I/O. We learned how to create and open files for read, write, and append, and different combinations of them. We have talked a bit about functions to read and write to files, either character by character, string by string, or block of data by block of data. We talked a bit about the importance of error handling, and I also think we have mentioned stdin, stdout, and stderr, the three default streams that are open when we just enter our main program. And there we go. And this was all, folks. I hope you enjoyed it, and now, as always, you need to go back to your computers and you need to start writing your programs and try it out and see how, well, you will learn as you write the code. That is the good way to go. So go away now, write your code, and I'm going to see you someplace else, perhaps on another topic. So thank you for now, and bye you all. Bye bye.